Now if we have f of x plus 3, actually let's read the instructions. F of x is a parent trig function. Now let's call that trig function sine or cosine because tangent's a little bit different. Okay, and we had to think, okay, if this is, say, sine x plus 3, you should know that that plus 3 is doing something to that sine graph. And you should know that that is your k value, and it simply moved it up 3. So that what we would probably write here is it's going to have up 3, which is called a vertical shift. Let's get used to those terms. We would call this a vertical shift up 3 units. That is a technical way to call it. We're shifting the graph up 3 units. Now for this one right here, well, the negative 2 in front does something else. What a number in front of a function, like negative 2 sine x, that's saying to stretch it vertically or shrink it. Well, since it's a 2, you're getting bigger, so you're stretching it versus shrinking. So this one would be called a vertical, not a shift, but a stretch. Now it could be a shrink, but this is a vertical stretch by a factor, sorry, A should have a space between factor, of 2. So it's a vertical stretch of a factor of 2. If that was a 1/2 in front, it would have a vertical shrink of a factor of 1/2. You're halving it versus doubling it. So now, there is also something else this is doing to it. The negative does something as well. There's a double thing happening. We tend to call that negative as a flip, but the technical term that you need to be aware of is it's technically called reflecting over the x-axis. So we want to call this reflecting over the x-axis. You need to be able to be aware this is another way of saying it. This is more technical. I'm okay with flip, but just be aware of that's more technical. Now this one, whenever you add or subtract something inside the function, what it's doing is it's shifting it left and right, which is called horizontal. Now, isn't that interesting? Isn't this called your h value? Horizontal h? Kind of even tells you that. H for horizontal. So we are horizontally going pi, but we have to think of which direction that's going. Inside the parentheses, we always went the opposite direction of what it said. So that would have been a positive direction, but we go in the negative, the opposite direction, which would be, hopefully you can see, as to the left. So this is going to be a horizontal shift, not a stretch. And we said which direction? Is it left? Because in the negative, the opposite. Left pi units. Now, if it was a negative, again, this would be in the right direction. So it's either left or right, horizontally moved. Now, this last one is unique to trig. We never talked about this with our other functions, okay, because we were waited for this chapter. It just fits well to finally bring it up because it kind of complicates it. So this is a new one. When you multiply the inside by 3, what that means is it's kind of like saying sine 3x or cosine 3x, and that deals with a horizontal shrink or stretch. What this is saying is you have 3 times as many cycles in your normal 2 pi period. So you could think of that as squishing a whole bunch more in the same space as before. So if you're squishing 3 cycles in what normally was 1 cycle, you're squishing it. So that would be called a horizontal. I'm going to abbreviate this one. And this would be a shrink. And it's by a factor of, now be careful, it's not a factor of 3, it's a factor of 1/3. If you're shrinking, aren't you thirding it? So it's kind of backwards. So you're horizontally shrinking this by a factor of 1/3. Now, here's a good help. Do you see how you're doing the opposite of what this kind of is telling you. A 3 usually would think, oh, I'm stretching it, right? But you're doing opposites. Isn't this also the opposite? Do you see how both of these that are inside the parentheses are opposites? They kind of do kind of the backwards of what it intuitively is telling you. So these two both do an opposite factor. So if that was a x over 3, which is a 1/3, you would be stretching by a factor of 3. All right, now let's give some trig terms to these. Let's talk about midline, amplitude, and period. So we got to think which one would be the midline, which one gives you the middle of your graph. Hopefully you can tell this one right here gives you the middle of your graph. And basically what happened is your graph got moved up, but it still has a middle. So our midline is in here, and the midline would be y equals 3. So make sure you understand, whenever you move it up, you're moving the middle of the graph up, whatever that, and then that is your midline. A lot of people forget to call it y equals 3. A horizontal line is always y equals. So that's important to make it that way. Now the second one. Okay, let's talk about period. Which one would be the period? The squishing it left to right, how far the cycle is before it repeats, kind of what period is. And hopefully you can tell that this one is the period. It's the horizontal stretching and shrinking. And so our period is always going to be in this spot. And could we actually calculate it? On a sine graph, our period, remember, we're going to talk about these as sines and cosines. For a sine graph, isn't our period normally 2 pi? And then don't we divide by the b? Well, isn't this your b value? That actually is the b value. So can I divide by 3? So there's my period. Okay. Now if that reduce it. Your period is now 2/3 of pi. Because that would give you 3 cycles in a 2 pi period. So make sure you can calculate the period and know that that gives you the period. That this number inside helps you find that. The last one of them is the amplitude. So which of these is amplitude? Hopefully you can tell that this one is the vertical stretch or shrink. So that's the amplitude. So your amplitude is going to be what? Well, hopefully you just notice it's a number. The negative is a negative part of the amplitude. No, negative just tells you if it's flipping or reflecting. So you don't need the negative, but the 2 tells you how much it's been stretched or shrunk. So that's your amplitude. So you need to be aware that you first need to describe it with our normal terminology, and then you need to give trig-specific stuff. Now again, if I had this as tangent, if this was a tangent function, would your midline still be 3? Y equals 3. Yeah. But what would be your amplitude on a tangent graph? Tangents don't have amplitude. It wouldn't exist. So that really wouldn't have it if it was tangent. This would still be okay. What's the period on a tangent? It would be pi divided by 3, because the normal period of tangent is pi. So tangent would be pi divided by 3. So that's why I kind of need to write this. Instead of just trigonometric, I should have said sinusoidal, meaning sine or cosine graphs. Because these two answers would be different if it was tangent. So we're going to focus on sine and cosine on this particular situation.